Now friends, we shall try our second order partial derivative. So till now we have learned our first order partial derivative, and there we take the multiple functions where y is a function of x1 and x2, and that our partial derivative, first order partial derivative, that was about del y by del x1 and del y by del x2. So they are the first order partial derivative. Del y by del x1, it is denoted by suppose f1, and that is del y by del x2, it is denoted by f2. So here f1 is equal to del y by del x1 and f2 is equal to del y by del x2. So f1 again, it is a function of x1, because f1 is equal to del y by del x1, so f1 is a function of x1, and f2 is a function of x2, so f2 is a function of x2. That means we can get the derivative of f1 with respect to x1 and derivative of f2 with respect to x2. Then it will be your second order partial derivative. So when you are trying to find out second order partial derivative, second order partial derivative, then it is given by f11. So what does it mean that f11 or f12 or f21 or f22? So what is f11? F11 means you are deriving, again you are getting the derivative of f1 with respect to x1, assuming your x2 as constant. Now here f12, that is you are getting the derivative of f1 with respect to x2, assuming here your x1 is constant. f21 means del f2, that will be differentiated with respect to x1, assuming x2 as constant, and f22, that is your del f2 by del x2, assuming x1 as constant. So when we are getting the derivative of first order derivative, then we are getting the second order partial derivative. So f11, we can write it as del f1 by del x1, or it is given by del f1 means del y by del x1, and it will be differentiated with respect to x1, assuming x2 as our constant. Now f22 suppose, so in f22 del f2, that will be differentiated with respect to x2, so it is given by del y by del x2, that will be differentiated again del x2. So here we are assuming x1 as constant. Now that we can write in other way, that is del square y by del x1 square, that is second order partial derivative, and that is del square y by del x2 square, that is the second order partial derivative. Now let us have a function y is equal to 2x1 square plus x1 x2 plus 3 x2 square. So here you have to find out f11, f12, f21 and f22. So these are the second order partial derivative, and we have to find out this second order partial derivative. So let us start. So given y is equal to 2x1 square plus x1 x2 plus 3x2 square, our f11 is equal to d square y by dx1 square. So to find out f11, first we have to find out f1, then we will be getting the derivative of f1 with respect to x1, then we shall find out f11. So first we have to find out f1. So f1 is nothing but del y by del x1, that is first order partial derivative. So as you know, here with respect to x1 it will be 4x1 plus, it is in multiplication form, so we are taking only x2, and del x1 by del x1 it will be 1, and this part will be 0 because it is in additive, it is an additive constant. So 3 constant, x2 constant with respect to x1, that part will be vanished. So that is our f1. What is f2? f2 means del y by del x2. So there is x1 is constant with respect to x2, it will be vanished. So this part will be 0. Here x1 is constant, x2 is variable. So del x2 by del x2 is equal to 1, and here we are having only x1 plus 3 into 2, that is 6 x2. So this is our f1, this is f2. Now f11 is equal to del f1 by del x1. So what is our f1? f1 is equal to 4x1 plus 4x2. So 4x1 plus x2. It will be differentiated with respect to x1, del x1. So that value will be, that is only we are having only 4. So x2 with respect to x1, here x2 is constant, with respect to x1 it will be vanished. So we are having only 4, that is f11 is our 4, and f12, what is f12? That is differentiation of f1 with respect to, that is 2, it is our x2. So f1 is our 4x1 plus x2 with respect to x2. So here x1 is constant with respect to variable x2, it will be vanished. So del x2 by del x2 it will be 1. Now f21 is equal to del, that is f2 with respect to del x1. So what is our f2? Our f2 is x1 plus 6x2, x1 plus 6x2, it will be differentiated with respect to x1. So here x1, del x1 by del x1 we are having 1, and 6 is constant, x2 is also constant, so it will be vanished. So we are having f21 is 1, and lastly we are having f22. So what is our f22? f22 is our del f2 with respect to x2 is equal to del, what is our f2? Our f2 is x1 plus 6x2 with respect to x2. So here x1 is constant, so with respect to variable it will be vanished. Now 6 is constant, so x2 is our variable, x2 with respect to x2 that will be 1, so we are having only 6. So finally our f11 is equal to 4, F12 is equal to 1, F21 is equal to 1, and F22 is equal to 6. You can verify whether your exercise is wrong or right. If your F12 and F21 value remain same, that is your process is good. So this is all about your second order partial derivative. Now we shall learn our total differentials. So in total differentials, again it is a multiple variable function. So here again y is a function of x1, x2. Now unlike your partial derivative, in partial derivative we have taken your x1 and x2, they are independent of each other. That is, the effect of x1 has no effect on x2 and x2 is having no effect on x1. So in that case, when we are trying to find out the effect of x1 on y, then we have taken that x2 as constant. Again, if you have tried to find out the effect of x2 on y, then we have taken the assumption that x1 is our constant that was in our partial derivative. Now suppose in process, if you know y is simultaneously affected by both x1 and x2, and you have to find out the simultaneous effect of x1 and x2 on y, then we shall go for our total differentials. So in total differentials, suppose we can take the example of your output. There is your production function q. Q is a function of labor and capital, and here you labor and capital both are having the simultaneous effect on your output. There is your production functions q, and you cannot find out the partial derivative. If you get the partial derivative here, then you will be having only the effect of labor on output, and you are taking the assumption that your capital is constant. And if you take the effect of capital on output, then you are taking the effect of labor as constant. But in your production process, when you are cultivating anything in your agricultural production process or in your manufacturing, we have to get the knowledge of the effect of change in both the inputs simultaneously on our output. Then we shall go for our total differentials. So we have to learn our total differentials. So in total differentials, that is given by dy. So dy stands for total differentials, and it is given by the partial effect of change in x1 on y, that is del y by del x1 into total change in x1 plus partial effect of x2 on y, that is del y by del x2 into total change in x2. So that is basically f1 into dx1 plus f2 into dx2. So that f1, it implies your partial effect of change in x1 on y, and that f2, it is our partial effect of change in x2 on y, and that is dx1 and dx2. That dx1, it is your how many changes you have done in your variable x1, and that dx2 means how many changes you have done in your variable x2. That is the total change in your x1, and that is the total change in your x2. Now suppose in your production function, q is a function of labor and capital. Now you want to know the total change in output when there is simultaneous change in your labor and capital. Then following this formula, del q by del L into dl plus del q by del k into dt. So what is this? Del q by del L, we know that is your so total change in output is equal to del q by del L is given by marginal productivity of labor into total change in labor plus this is your marginal productivity of capital. that is MPK into total change in your capital, so that is DK. Now if you know the marginal productivity of labor, suppose it is 2, and how many changes you have done in your total labor force. So you have increased your labor force, suppose you have added 5 more laborers. So if one labor is having the marginal productivity is equal to 2, and you have changing the total amount of labor, that is 5, then the productivity from labor, that will be is equal to 2 into 5, plus that is the marginal productivity of capital, suppose that is 3, there is marginal productivity of a single labor, that is 3, and you have added suppose 6 capital, 6 new capital, that is your total change in your capital stock. Then your multiplication of these two, that will be 6 into 3 into 6. So there is the total contribution of capital, and there is the total contribution of labor. So that is 5 into 2, that is 10, plus 6 into 3, that is 18. So total change in Q, that is equal to 28. So that 28 that we have obtained from the change in your labor and change in capital simultaneously. So we have to learn our total differentials when we are we have to find out the output or any variable, and that is affected by the multiple variables simultaneously. Now let us have an example. Suppose find out total differentials, where the function is y is equal to 2x1 x2 plus x1 square minus 2x2 square. So we have to find out the total differentials. So it is given by dy is equal to del y by del x1 into dx1 plus del y by del x2 into dx2. So our del y by del x1, that is your y when it is differentiated with respect to x1, then we are having from that there is 2x2 plus 2x2, and that part will be vanished when you are differentiating with respect to x1. So 2x2 plus 2x2 into dx1 plus y with respect differentiated with respect to x2. So here if you differentiate this with respect to x2, so 2x1, that part will vanish, minus 4x2 into dx2. into dx2. So that is our del y, that is our total differentials. Now let us have another example. Suppose find dy of the function, where function is y is equal to 2 log x1 square plus 10 minus x1 x2 square. So dy is equal to del y by del x1 into dx1 plus del y by del x2 into dx2. So let us first find out del y by del x1. So del that is y get the differentiation of this part, then we are having 2 by x1 square into differentiation of x1 square, that is 2x1 plus this part will be 0 plus that will be minus, here minus sign is there, so minus x1 x2 square. So with respect of x1, so we are having only x2 square, and that is multiplied by dx1 plus del y by del x2. So if you differentiate this whole things, then this part will be 0, this part will be 0. So we are having minus with respect to x2, so 2x1 x2 into dx2. So finally we are having that is 4 here x1 square, so 4 by x1 minus x2 square into dx1, and then to multiply, then plus will be minus, so minus 2x1 x2 into dx2. So that is your total differentials, that is dy when it is simultaneously affected by x1 and x2. This is the process of getting the total differentials.